So good evening, and I'm really delighted to have the honor of moderating this session with my two friends over here, Mr. Nishant, who is the Senior Vice President at KPIT, one of the leaders in propulsion systems. So we'll get more into that on the topic of clean fuels and so on. And we have Piyush, who's the Chief Technology Officer at L2M Rail, looking at various aspects around advanced sensors related to safety, specifically for Indian Railways, which is a hot topic and context today, right? And it's very interesting how these two seemingly separate areas related to mobility, propulsion, and sensors actually play a very critical role in ensuring a safe, accessible, and sustainable path forward for India's mobility story, right? Be it in personal or in the logistics industry or heavy transportation industry going forward, right? So I hope to, that we have the 20 minutes or so to have an engaging session where they can share their thoughts, their use cases on which they are working on, so that it becomes more engaging for the audience, as well as, what's to come forward, right? So over to you, Nishant. If you could just step, and help enlighten the audience on the specific problems that you work on in propulsion and the use cases, and then we'll take it from there.
Sure. I think it's a nice segue into this session from earlier session because we were talking, I think the fellow panelist talked about sustainability. I think, if you really look at the clean fuel, everybody is talking about electrification, right? I mean, there is a big word in the mobility industry today about electrification, but it is not really about electrification. It is really, electrify, the current mobility system. So it is not necessarily, everything going into a battery electric vehicle kind of it. We really have to look at the overall kind of energy demand, countries like India and global has because mobility is not only, let's say, the personal mobility, because mobility, I mean, our friend is going to talk about railways. So it's really a multimodal mobility, including the industrial sector. So the fuel, the clean fuel, which is a topic which we are going to discuss, it's really not, limited to the battery electric vehicle or electrification. We have to really, look at the multitude of powertrains. So we at KPIT has an opportunity to really look at, how can we improve, the different powertrains. So of course is the electrification, which is battery electric vehicle. Again, in that also the battery chemistry plays a big role, right? I mean, the lithium is not available in India. So can we look at alternate material for battery to kind of make it more sustainable? Is it really true sustainable, right? Because from the, the really, there is a term we call it's a wheel to well, right? So is really, are we generating the clean? But also in the fossil fuel, right, there is a lot of opportunity to improve and increase the efficiency of, these fuels. And we see already, I mean, the earlier session we were talking about biofuel, right? So we already see, it is methane, or people are talking about biofuel, in the mobility industry. Ethanol, I mean, two days ago, our minister, of transportation, Gadkari sir, they have already announced now India will look at ethanol not just for the gasoline or petrol vehicle, but also for the diesel vehicle. So one side, improvement in fossil fuel vehicle is a continuous problem. Then we have hydrogen, hydrogen ice, and then of course the battery electric vehicle. So we see this, the multitude of powertrain and then controlling, these engines with the multitude of powertrain with sensors and different technology is really a challenge, and maintaining the CO2 reduction as a goal, what we really have from the sustainability point of view. So that's why I said or started my statement that it is not only electrification or a clean fuel, it's a electrify. So reduce CO2 using multitude of available technology to really help our overall goal of ESG.
Thanks, Nishant, for that, because I think important takeaway is, yes, electrification, BEVs, hydrogen, etc. But we also have to acknowledge that fossil fuels are going to be here for a while. How do we improve the efficiencies, drive down emissions, while there's a gradual taper up of other more sustainable technologies, so to speak, right? So,
Yes.
yeah. On the other end of the spectrum, one we have is propulsion. The other thing is, having worked in the EV space and in the emission space for a while, I cannot understate the importance of sensor technologies, right? I think they form the underlying substrate for anything related to mobility, safety in any industry. So I have here Piyush to talk more about the fantastic work that they are doing and to chime in with thoughts on the sensor space.
Thank you, Narayan, sir. Good evening, everyone. I'm CTO of company Lab2 Market Innovations. In short, we tell L2M Rail. So what we are into, we have a clear vision that we want accident-free Indian Railways by 2030. It may look a very impractical or over-ambitious vision, but then this is something which is really required, and the plethora of accidents which have happened recently in last couple of years, it emphasizes that we really need to have a much more safer and secure system for running trains in India. And we have already developed 4 technologies which have been rolled out, available at 7 different locations across the country, and we are already developing 4 more technologies. But the more important part is, in all of this, sensors is a big backbone. There can be a different kind of sensor, but yes, every time we want to monitor, we want to control the accidents, we want to alert Indian Railways in a timely fashion. Sensors play a very, very big role. Yeah, so I thought you were, no problem, okay. So there are different kind of sensors which we work on. Like one of our technologies, it helps in monitoring the health of the wagons on the go at 100 kmph. The Indian Railway method of doing that activity is, they sit along the track, train has to run at only 15 kmph, they turn on the lights and they see for any kind of defects. Purely human intervention, nothing else. However, our system is able to do the same thing at 100 kmph for one of our clients, that is Dedicated Freight Corridor, which is nothing but a sister subsidiary of Indian Railways. Here we use sensors, FBG sensors, which are used for strain, and contactless, basically the camera sensors. So based on the input from the sensors, then comes all the layers of software, other hardware for stability, artificial intelligence, machine learning, computer vision, signal processing, and the UI. But until we get the reliable data from sensors, nothing can be done. Similarly, we have another technology which is utilized for wheel monitoring. Now, this technology we have already deployed for 2 different locations within Bangalore. And it is reaping its fruit. From last 3 years, the technology is working, and it has helped Indian Railways stop 405 coaching trains. Stopping 405 coaching trains means directly averting 405 accidents. All this is possible because of smart sensing. And the wagon monitoring, what I was talking about, there our client is having, they are stopping 1 train per day on an average from last 6 months. So in India, the mindset is the accidents are criticized a lot, but the prevention of accidents is not embraced, it is not appraised. So coming back to one more technology which we have, it again takes care of sensing part through FBG strain sensors as well as FBG displacement sensors. And on top of that, we have other sensors also which we are working on, such as LiDAR, which we are working on a technology to prevent any kind of sabotage, to prevent any kind of foreign material not getting noticed and trains are hitting into it. These kind of things, they require immense accuracy, because the train should not stop just because of your false positives. If the system says that there is a foreign object, there must be a foreign object. So you require plethora of sensing technologies combined together to give one particular solution, to give one particular output, that yes, it is 100% short positive. For that, we use LiDARs. 3D LiDARs, 1D LiDAR. We have been already working a lot on cameras, be it underscan cameras, be it line scan cameras, high precision, thermal cameras. At the same time, we also work on sensing FBG sensors, be it for bridge inspections, be it for strain, be it for displacement. And we are also working on distributed acoustics, basically distributed optical sensing. In case, why that is useful is, suppose an elephant is crossing the track. Now, based on that vibration, it is not possible to use spot sensing, because it can happen anywhere. Or if there is a landslide prone area, a big boulders fall down, you cannot predict where exactly it will happen. But yet, you need to stop the train at least 1 kilometer, 2 kilometers before that. So this requires distributed sensing. So we are already into these kind of sensing technologies, and I will again emphasize that without smart sensing, it is absolutely not possible to control, to remotely monitor, to detect anomalies in the mobility sector.
Thank you so much, Piyush. So if you look at the overall ecosystem that both of you work in, I'm kind of in the middle, consuming or using your technologies, right? You briefly mentioned about some of the challenges. Where do you see your technologies evolving further from a clean fuel perspective or from a smart sensing perspective? Because these are the needs of the day to day as we are trying to reduce emissions, with climate-related challenges becoming more pronounced on a daily basis. It becomes more important to have advance warning of various types of situational problems that might arise that could lead to safety and other challenges, right? So maybe Nishant, you could start with, where do you see yourselves going forward? Where do you see this area of propulsion itself evolving as you're leading the forefront of it, at least from an Indian context, if not globally?
So maybe I want to answer this in two parts. One is on the technology advancement part, and then where I think which technology probably has more opportunity in India, kind of a scenario. So the technology-wise, I think today's automotive technology is really I would say the fusion of multiple technologies. There is no more a single technology. It's not in car, but there is a lot of things happening out car. So, I saw today in exhibition, someone is, really showing a very unique application of digital twin for a battery. Right? One of the big problem, we all have seen that for the battery electric vehicle, if it is not managed properly, right, with respect to the temperature current, there is a chance of battery getting exploded. We have seen in India, a lot of two-wheelers, four-wheelers has happened. So predicting that thermal runaway is a big challenge. And of course, with the existing sensors technology, like temperature sensors and all that, we can predict to a certain extent, but it is not enough, because the battery is extremely non-linear in characteristics. So it is very difficult to really, create a physics equation to really solve a problem of thermal runaway, where we need to kind of use the hybrid algorithm, which is, machine learning based, AI based, or digital twin, which is the hot topic, right? Everybody talks about digital twin today, where we are not just using physics, but we are also using data and kind of predicting that, right? So like that, I can go on and talk about in multiple propulsion areas, different challenges. So the technology wise, I think it's no more just a control system. We need to apply the IT technology, the embedded technology, this whole AI thing, a lot of heuristic based calculations. So that's really with a multiple sensor. So means just to give you, a perspective, if I look at a diesel engine controls, there are 45,000 parameters based on sensors and actuators, which we need to calibrate to ensure that we meet the BS4 or BS5 kind of an emission, right? So 45,000 parameters calibration is not easy job. So the complexity of technology is huge, where we see that multiple. So that's really on the technology. Opportunity, I think, there is a lot of opportunity in, for us to be independent on, let's say, the lithium import. There is a big research happening on sodium ion batteries. And, we at KPIT also has came out with a solution, because sodium is abundant in, everywhere, including India. And can we at least look at some application like city application where sodium ion battery? And the other is, of course, the fuel cell hydrogen, where everybody is looking at. So I see that not probably in 2025 to 2030, but after 2030, there will be a mixture of technology, including hydrogen, and that will become a mainstream where India can really take a lead, in production of hydrogen, and then of course, using that as a powertrain fuel, clean fuel, to really, give a mobility sustainable, but most important, affordable for everyone.
Thank you so much, Nishant. So Piyush, as you have worked on so many areas related to safety for railways, the technology that you have built, I'm sure has lateral applications that you can find in many other areas. Perhaps you may want to chime on that, plus where do you see yourself going, and where do you see L2M going forward?
So if I talk about the extension of these technologies or these kind of sensing technologies across other sectors, road sector is definitely something which can take immediate use out of it. Suppose, like just an example, if the sensors can sense the train movement, it can also sense the vehicle movement. If we feel that the traffic lights can be controlled in a way that if more than X number of vehicles are crossing the particular sensor, distributed sensor, this means this particular route should be given priority for giving green signal to decongest the traffic. Or if an ambulance is crossing over that, you understand, okay, there is an ambulance, that means this signal should communicate with the next signal also to give a continuous green corridor for that ambulance. So there are a lot of such applications which can be easily done combining cameras, combining strain sensing technologies, and there's so many flyovers being built today. Okay, what is the monitoring mechanism? How do you know after 5 years that will not collapse? This requires continuous monitoring. It is not about when it is about to collapse, when you see the crack, then only you will act. Can we have a system where the sensors are embedded into that, and we can continuously monitor the performance? We can continuously see the degradation, and beyond a certain benchmark, it is, we can convey that now it is no more safe for usage. So there are so many applications which can be directly related to the road. Same for aircraft, but then I think the costing would be way too much, because it takes like the kind of safety parameters and the kind of efficiency we need, be in terms of weight, be in terms of other activities, it is totally different. But yes, for road network, it is something which can be easily copy-pasted with certain amount of change in the software.
Okay. I do see that our clock is winding up, and this is an enormously vast area related to fuels, propulsion, and sensors. So I think I'm happy to open the floor to any questions from the audience. And maybe you can take one or two. Yes, sir.
Hi, my name is Aditya. I'm the founder of ChromoPic Sensing. So I have a question for Piyush. So when you mentioned the fiber Bragg grating sensors and LiDAR sensors, LiDAR I can understand you're basically sensing the line of sight. And is it mounted on the train or is it off the train? And how is FPG mounted as well? Just curious. Thank you.
So FBG is mostly on the track, not on board, while the LiDARs are more useful when they are on board. I hope it clears right?
Got it. So how does it, how is FPG coming into what kind of obstacle you have on the track or by the periphery of the track? And also, are you working on the sensors? Are you working on the integration stack of camera, sensor fusion sort of layer?
So the answer would be both yes and no. Okay, we are working on sensors. We are working on the equipment the components which are required for integrating the sensor data. At the same time, we are trying to take what is readily available in the market to go quickly into the market. So both ways we are doing it.
Appreciate it. Thank you.
Yes, sir.
Yeah, hi. It was a very good talk. Question for Piyush. My name is Rajesh Kapuswamy. Piyush, the work that you're doing on the trains, I mean, it's Indian Railways are being sabotaged right now, so that's a more smarter work. I see one correlation directly for the borders that we are building, border fencing that we are doing in the eastern side. Do you see an application of your sensors on the border fencing which is being done right now? And the other subsiding questions, I'm not a hardware guy, I'm a software, but when you put your sensors, how long will the sensors actually be able to sustain on battery? How's their power source? How do you manage that? Thank you.
It's like why I was emphasizing on FBG-based sensors or optical sensors was this purpose only. FBG sensors don't require any power supply. And number two, the component which is reading the light, it can be 2 meters away, it can be 20 kilometers away. It doesn't matter. So one thing, you don't need to have a reliable power supply near the track. Number two, it avoids any kind of interference, electromagnetic interference from the OHE, which is having 25 kilovolt of voltage of power. So that way, both the ways it helps. And third thing is definitely the reliability. Fourth thing, your security of the data. Since you're not using MEMS sensor or you're not using any other such sensor which works on voltage and current, nobody can mend with it. Whatever once you have installed, you have fitted, it's good. Nobody can interfere with the system. I hope it clears it, right? Thank you.
All right. So thank you so much, Nishant and Piyush, for giving an express overview of what's going on in this area. Please connect with them offline. There are so many topics to talk about: clean fuel, sensors, redundancies, and so on. So thank you very much.